Section 3.4, homework problems number 3 and number 4. So we're going to look at these two problems together because they're very similar. So first of all, we're going to learn how to convert a mixed number. 2 is a whole number, 3/4 is a fraction. So we're going to convert this mixed number to an improper fraction. So from mixed number to an improper fraction. And explain in your own words why the procedure makes sense. So we learned in algebra class, we were told when we convert this fraction, mixed number to an improper fraction, we multiply. So first of all, we keep the common denominator 4. I'm sorry, not common denominator, just the denominator 4. But the numerator is going to be 2, whole number 2 times the denominator plus the numerator. And that's the process we memorized. But we need to explain as teachers to our students why. First of all, why do we keep the denominator 4? Secondly, why do we multiply to the whole number 2 and denominator 4? And lastly, why do we add the numerator to that? So we need to explain every single step here. Again, we can use the drawings to help us. So first of all, we are going to use strip diagrams to demonstrate the mixed number we are given. So the mixed number we are given is 2 and 3/4. So we're going to, 2 means 2 ones with 2 wholes. So 2, this 2 means we have 2 wholes. And 3/4 means we have a quarter of a whole. So first of all, when I did this, when you start, you would just draw 3 holes with exactly the same size. Because again, in one problem, the holes, in one fraction, we must have one problem, we must have the same holes unless specified otherwise. So we have these 3 holes. So that's 1, 1, and 1. And notice we have 2 holes, so we do have to take both of these 2. And next we have 3/4. For the third hole, we are going to, let me just highlight this instead of that. So we have 1 hole, 2 holes, but for the third one, we don't have a hole, we only have 3/4. So we're going to have to divide this into 4 equal parts. We're going to shade 3 of them. So for the last one, in my picture, you can see, so originally when you have 2.5, so that's all these 3 together demonstrates 2, sorry, not 2.5, 2 3/4. All of them together shaded in the highlight, in the yellow. And next, we're going to see how do we convert this into improper fraction, which means we don't want the whole numbers to be there. So we want to get rid of that whole number. So what we do is, we need to figure out, so we already know the last one, it's easy. We have 3/4, which means 3 parts, each of size 1/4. But these two, so this is what we want to know. We want to know how many parts. We want to get an improper fraction, which means you don't have a whole number in front of it. You just have a numerator and denominator. And so again, remember the top means the number of parts. So we need to know the total number of parts. And the bottom, of course, tells how many, the size of the parts. So of course, it makes sense if we divide the other 2 holes into the same size parts, so we can add them. If they have different sizes, we cannot add them. So we're going to also cut the other 2 holes into 4 equal parts. So now, notice like we're gonna count. Now we're gonna add how many parts we have together. So that's why in my drawing I have these 2 holes. This is the first hole, and this is the second hole, and this is the third hole. From here all the way to here, here to here. But then I divide the first 2 holes into 4 equal parts, because I need to count how many parts of the same size together. So notice we know here there's 1, 2, 3 parts. So I can get rid of my drawing, just use the drawing, and you see how we get that. Okay, so now we're going to look at, so again, 2 from here all the way to here represents 2 and 3. maybe I should separate them into 3 parts. So that's a 1, that's 1, and that is 1, that's together 2, that's 3/4. So when you add all of these together, that gives us 2 3/4. But we want to get rid of that whole number, just turn that into how many parts and the size. And so now we turn all of these into the same sizes, and we can count how many parts together. We already know there's 1, 2, 3 parts here. We just need to figure out how many parts are in the first whole and the second whole. And notice, if you remember, we divide each whole into 4 equal parts. 1, 2, 3, 4. 1, 2, 3, 4, which is determined by the denominator, because this fraction determines how many parts we're going to have. So 4. And so notice the 1 whole has 4 parts. 2 wholes has 2 fourths. 2 times 4, 8 parts. And of course, you can do count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But we want you to figure out a systematic way to do this. So for example, if you think this way, okay, if you have 1 whole, let's write here. So if you have 1 whole, which means if the whole number is 1, then you have 4 parts. But if you have 2 wholes, that's 2 fourths. So you do 2 times 4 parts. But if you have 3 wholes, of course, we can stop here for this problem. But if I change this number to 3, if you have 3 wholes, this pattern also works. So you will have to, the third whole will also become another 4 parts. Then you have 3 fourths. See, 1 fourth here, 2 fourths here. If you have one more, 3 fourths or 4 fourths and 5 fourths. So in general, you would just take the whole number, because each of the whole number is turned into 4 parts. So 1 whole is 4 parts, 2 wholes, 2 fourths, 2 4 parts, so which is 2 times 4. So why do we, in the process of converting, why do we do 2 times 4? The explanation is because each whole is turned into 4 parts. And then we also, of course, we have to add these 3 parts out of the 3/4. So why do we add 3 to that? And notice the bottom tells us this, and notice that each of them is divided into 4 parts, and the size is 1/4. Each of these has the size 1/4, and the 1/4 and 1/4. So that's why the denominator doesn't change. That tells us how many parts did we divide each whole into. So we divide each whole into 4 equal parts. So we get 11/4. Okay, so that's how we explain why we multiply the whole number in the denominator, because each whole is turned into 4 parts. And why do we add that 3? Because there's a little bit 3 parts left. We added to that. So that tells us the total number of parts we have. And the bottom number is how many parts we divide each whole into, which is 4. Okay, so next, example 4. I picked, I think for this problem, you could just use, pick any fraction or mixed number. I picked the same mixed number, 2 3/4. This time, we don't use strip diagram, we use a number line. The idea is very similar. The number line in one of the in one of the sections we did in section 2.2, we also had a question asking if you have improper fraction or mixed number, it's better to use the number line. And the problem with the strip diagram, some students might think all 3 strip diagrams are the whole, but actually each of them is the whole. So you actually have more than 1 whole here. But with the because we don't really label, unless you label it like I did, first whole, second whole, third whole. So students will see, oh, actually there are 3 holes here, not just 1 whole. But with the number line, they are all automatically labeled. So again, it's very similar to the process we did. So you draw the number line, you label 0, 1, 2, 3. And because for each unit, so from 0 to 1, you're going to divide. Actually, first, we didn't have to divide these. So when we started, we draw a number line, and we label 0, 1, and 2, and 3. But since we have 1 and 2 and 3/4, how do we draw 3/4? Again, we'll talk about this in section 2.2. So you divide into 4 equal parts. 1, 2, 3, 4, and you stop right here. This is 1/4, 2/4, and 3/4. And again, in order to turn that into a mixed improper fraction, we also need to turn these two wholes into the same size parts. So we are going to divide them into 4 equal parts here, 4 equal parts here. So that's why I have those also whole numbers cut into the same size parts. And after we do that, and again, remember, each of them has size 1/4 because we divide this one whole into size 4 equal parts, which means each size is 1/4. So now we have 1/4, 2/4, 3/4, and 4/4. Keep counting. 5/4, 6/4, and so on. But of course, this we want to find a system mathematical way. So we are going to see the same idea. Each whole is turned into this one whole is turned into 4 parts, and 2 wholes it is turned into 2 times 4 parts. And plus we also have 3 parts right here, so that's 3 parts. So altogether it's 2 times 4 plus 3 parts, which gives us 11 parts. But the size of each part is 1/4, so we have 11 fourth parts. 11 parts size, each of size 1/4, which is the fraction 11/4. When you put them in words, you will say because we break 2 wholes into fourths, and there are 4/4 for each whole. So one whole 4 parts, and 2 wholes 2 4 parts. So you have 2 4 parts. That's the total number of parts in the wholes plus the parts. That's 3 parts in the fraction. So together 11 parts. Well, you can the parts you can say the parts instead of fourths because the each part does have a size 1/4.